give everybody about 1 more minute. We still have some folks rolling in, and we'll get started here in about 1 minute. All right, good afternoon, everybody. Thank you for attending. Thank you for joining us. Special thank you to LaserTech for putting this on with us. This presentation is going to be on remote measurements and electric utility applications. Our speakers today, we've got Steve Colburn, who's the application training specialist at LaserTech. I am Peter Thompson. I'm the Utility Solutions Business Development person for North and South Carolina. And then we've got Derek Rash, who's the Senior Production Manager for LaserTech. So again, thank you to both of them for joining us. And we'll give a quick overview of who Duncan-Parnell is. We are celebrating our 75th anniversary this year. We're extremely proud of that, and we thank each and every one of you on this call, because without you, that wouldn't be possible, along with all of our other customers as well. So we are still family owned. We cover the Mid-Atlantic through the Southeast. I checked the registry for this webinar, and we had somebody from each of our states and quite a few from outside of our territory register. So again, welcome. Thank you all for joining. This is probably heavily a geospatial group, but we also have within Duncan-Parnell signs and graphics for all your signage needs, 2D, 3D printing, reprographics, and then we've got some building point stuff, which is our construction side of the house, as well as additive manufacturing, which isn't here. So again, that's Duncan-Parnell. We'll get started. I think we're going to have Steve or Derek first. I'm not 100% sure.
Yeah, I'll go ahead and introduce LaserTech. Peter, thank you. This is Steve. That's 75 years. That's great. Our two co-founders just celebrated their 35th year being in business together, so we've reached that milestone. And yeah, LaserTech is a company based in the Denver, Colorado area. We've been there the whole time. Really pride ourselves in producing quality products, many of them right from our factory there in Denver. And really one of our claims to fame is our service and support. We really try to provide that to our customers as best as we can. And yeah, just real proud of the products that we produce. And we talk about worldwide distribution here, but we definitely have great distribution across just the country here, and definitely represented by Duncan-Parnell in the Southeast region. So we're proud to be partnering with them. So a little quick overview of what we're going to cover today. We're really going to delve into the electric utility industry in particular, give you some examples there of the measurements that they require, some of the equipment that's in use today, and then how our laser products can really shine in this arena and make these measurements that need to be done. Give you some results right on board the units, good user feedback, and go over how some of these measurements are documented in these cases. And then we'll get into remote measurements and taking offsets with the lasers. So here in this electric utility arena are some of the applications that need to be performed, and the lasers really perform well at. On the transmission side, you've got vegetation management, and then even some engineering applications like span, sag, and tension. On the distribution side, examples like pole audit, strand mapping, and then many of the utilities have a GIS department that's involved with mapping in all the facilities that they have, maintaining things that are in their right of way, things like that. So, you know, not an exhaustive list by any means, but a few of the examples. And in each of those, you've got the different techniques that can be used to gather the data, you know, and then how to document it all as well. So we're going to take pole audit here, like joint use pole audit as an example, and really delve into why these types of measurements can be made. It's kind of a hot topic, hot industry these days, with the you know, our increasing demand for communications services primarily, but also electric power as well. So it really comes down to regulatory. The electric industry has regulations that they have to adhere to, the NESC here, and you know, the pole owners, who are usually the electric utilities, constantly having people, you know, want to put more facilities up on their poles, use them to distribute their services and everything. So there really has to be a lot of inspection and engineering done to make it all happen. So that's, you know, there's a lot of people in the game. There can be contractors, the telecom companies, the electric utilities. So there really has to be a lot of inspection done with a good deal of accuracy, because there can be some dire results if you don't get these measurements made correctly.
Hey, Steve, this is Derek. I was going to ask you about that. How often is that these pole audits performed?
Well, it really can be any time. The electric utility might do it on a regular basis just for structural assessment. But then, you know, when the telecom wants to come in and hang something on the pole, they have to do it. It can be really done in many different ways. You guys have any other input, Peter?
I don't think from a regulatory standpoint that it's on a set time frame, but I think it's just supposed to be done regularly.
Yeah.
Yep.
So one of the primary measurements that needs to be collected, particularly for pole audit, would be the HOA, or the height of attachment. So, you know, you've got the different zones that you need to adhere to, the electrical supply space. You have to have some neutral space then in between that and the communications area. So all these things need to be cataloged for that particular application. And heights can translate over into telecom tower type heights, you know, inventorying a tower of all the different attachments on there, something like that. And then span values is another one, you know, that distance between two objects. Could be pole to pole, you know, or over a roadway or river or something like that. Anytime you need to make those horizontal type distances between two objects. Clearance values is another really important thing that needs to be done. Again, in the pole audit example, anytime that wire is going to go over a roadway or walkway or anything like that, a clearance value has to be measured. So you've got, you know, that overhead clearance under wires, but then also vegetation management, you know, along the edge of the right of way. That distance between it and the nearest wire needs to be really accurately controlled. So those are some of the values. It may even be, you know, a clearance could even be a sag value, you know, some kind of vertical distance between 2 points. So we'll talk a little bit about some of the equipment that's being used to make these measurements out there. anybody, you know, doing distribution type work for the electric utilities is going to be familiar with the height stick, and potentially a wheel for measuring distance. But you know, we've kind of described the basic workflow process here. You've got to physically occupy each point. You've got to go up to the pole and raise the height stick up there. You've got to, you know, walk that wheel in a straight line between the two poles to get the distance. You've got to touch the attachments potentially, and even a hot wire. So there may be safety gear involved with using the height stick in some cases. And then oftentimes, you know, it's kind of a low-tech solution, so they're probably handwriting notes and everything when they're doing this. Another piece of equipment that can be used are drones, gaining use and acceptance. You've got to go out and do your pre-flight planning, you know, in a crowded urban area where properties are real dense. You may not have permission to fly over certain areas, so it can be kind of tricky doing that planning. You've got to then lay out your ground control points, make sure those are all in to your desired accuracy and things. You go out and fly the mission, collect the data, and then process it for interpretation. There's really not a whole lot you can see on site, but it's done back in the office. So, you know, usual things with drones, you get into crowded areas like as pictured here with wires everywhere and everything. You can see how it's pretty tricky. You know, the wind kicks up or something. So you've got to pick your times where you can make the measurements. There's also all-in-one type devices that are used. Again, thinking about the pole audit application as an example, but it's a data collector, a GPS unit, a laser rangefinder, everything kind of integrated into one. You calibrate the unit, put it on a tripod, record your measurements, and then you get a little bit of feedback there in the field, but a lot of times, again, it's processing the data back at the office. And typically on this devices, there's you can see there's no kind of sighting scope, so you're kind of using the video camera on the unit to do your sighting. So, you know, some of the driving forces behind here, obviously, your safety, right? The results of not properly cataloging a pole, for example, and its engineering limitations can result in failures, or not measuring a proper clearance can result in bringing heavy machinery underneath somewhere and causing a problem. So that's really one of the driving factors that we're looking at here. And Derek, we feel like the laser tech products really can address some of these challenges from some of these other measurement equipments, right?
Exactly. Yeah, exactly, Steve. Thanks. Just, you know, our laser rangefinders, you know, no non-contact, like Steve was talking about with that height stick or the wheel. You got to get right up to a certain area, so you can stand back in a safe location utilizing our lasers. You know, one-person operation, which is really good. We're going to talk a little bit about that, and you can see the results in the field. We're, you know, like Steve talked about, we're going to talk about how you can see the results right there in the laser rangefinder, and also capturing all this information in different apps. And so we'll go through all that. So just a little bit about Laser 101, what our professional lasers have. We've got our laser sensor or laser diode in there that measures the distance. There's no need for a reflector. Second person, it's reflectorless technology. So we're able to get distances to almost any type of object. You need to be able to see it, you know, of course, through our heads up display there, you can see, and that's basically scope shots you're seeing there. That's what you're looking at. Another sensor that we have in all our lasers is the tilt sensor. This measures their angles, you know, for elevation and heights and everything. That will be all the different values that Steve is talking about. So the tilt sensor there, plus or minus 90 degrees, there's really no limitations with that. So that, which is great. We can measure, again, plus or minus 90 degrees. And then on some of our lasers, we have a compass sensor. The compass sensor measures azimuth or direction. And this is another one that has no tilt or roll limitations. So you can still be at like at 45 degrees, taking a measurement to the top of that pole and get a very accurate azimuth measurement. So that's that's no limitations with our lasers taking these type of measurements. And we have devices that have an angle sensor, especially like with the compass. It can be affected by magnetic interferences. If you're close to your vehicle or buildings and everything, that azimuth values are going to be not as accurate as might be needed. So we have an angle sensor built in some of that. So we can still get our horizontal angles. So you get that distance, that tilt, and still that horizontal angle. So it's still a 3D laser rangefinder. So what does that actually look like? What do those measurements look like? So the laser gives us our slope distance, or SD, line of sight, whatever you're looking at, we get that distance. The tilt gives us our inclination. These are values that you actually see in the display of the laser rangefinder. And then when we incorporate the compass, we get our azimuth, the degree of azimuth, the AZ. You can see on the right-hand side our 3D measurements. So with the press of the fire button and looking at the object, taking fire, acquire these measurements, all the sensors measure, and then on board we calculate that VD value, or vertical distance, and also that horizontal distance. All these values are measured and calculated at the same time. So you see it, you can scroll through the heads-up display, looking at all the different measurements, and at the same time, these values are outputted via a serial string, an RS-232 port, or also Bluetooth that I'll talk about here shortly. So our 2D lasers, the TruePulse 200 series, you can see here TruePulse 200 and the 200X. On the TruePulse 200, you see the range accuracy plus or minus 8 inches. And range, as we get out there, a lot of distance. I mean, over 3,000 feet. This does have Bluetooth communication, but it is a classic Bluetooth, so it works with Android and Windows devices. Then our 200X, you see that we've increased that accuracy. That's a higher accuracy unit. You can see there's scope shots there. The left-hand side of the 200 is an LCD, and the right is an LED. So we have different scopes also to look through. The range accuracy of the 200X, we're down plus or minus 1.5 inches. And you see the inclination accuracy. And this does have it still has Bluetooth Classic mode, but we've got an iOS approved chip inside. So we can talk to those iOS devices with the 200X. When we incorporate the compass sensor, we call this the TruePulse 360 series. We've got our 360R and our 360 model. If you look at the different specs there, they're all the same with the range accuracy, inclination accuracy, and our azimuth accuracy is what we really look at when we incorporate that compass. We're down to a plus or minus half a degree with the azimuth accuracy, which is really, is great with these instruments. Again, these both have Bluetooth communications. It's the classic, working with Androids and Windows. But the main difference between the two models is the ruggedized unit. Oh, that's all right. Yeah, is ruggedized to the waterproof housing is the 360R. And so, and you can see the configuration, more of a horizontal configuration. Now, when the compasses could be affected by magnetic interferences, like your vehicle or buildings, if you're too close to them, we have that horizontal angle in a true angle. It's a modular system here. You can see that, and you can use that with any of our TruePulse models. So we have it here with the 200X because you can see the accuracy of that horizontal accuracy. We're down to 1/10 of a degree and even less. So kind of combining these two high accuracy units, you get a really good, accurate 3D measurements. You'll still be able to use Bluetooth because you don't have to have a cable going from the true angle to any devices. It's we have what we call a Bluetooth loop, and it just goes back up and sends the signal right outside the TruePulse laser rangefinder. One of the newest models that we just released is called the TruePoint 200H. This actually takes our pulse technology I've been talking about, the reflectors technology that is in our TruePulse models, but we've also incorporated what we call phase technology, or a laser distance meter, where you actually see the red dot you can see the red dot for measuring. We combine these two technologies into one device, so you can see the accuracy you can get on the range accuracy, and we shorten the range on this to maintain this accuracy of this unit. So you don't actually choose which technology you're using; it does it automatically. You start to try to acquire a range to a target. It's going to try to get the best measurement possible. If not, it flips over to the pulse, and you don't even see that change, except for the resolution. You know which one, the accuracy you're getting through the resolution. This does have two Bluetooth modules inside. It's got the classic, and then it's also, we put in the BLE. So now with the BLE, it automatically connects to all different iOS devices, so very seamless. So we've got two different ways of doing the Bluetooth connection. The last model talking about is a TruePoint 300. This is a phase technology laser, so it's a laser distance meter, but also has a vertical encoder and a horizontal encoder. So it's a 3D measuring tool, kind of like a miniature total station right here. You can see the accuracy of this unit is, 5 plus or minus 5 millimeters, so very accurate. The max range is on this is 300 meters and everything. It does have communication, so it's got Bluetooth, but with the Bluetooth you get the 2D measurements. For the 3D measurements, you turn it into a hotspot using WLAN or Wi-Fi to capture those 3D measurements. So we have a lot of other things besides just range. These instruments are able to calculate different routines, and Steve's going to talk about all the different routines that are built on board of these lasers.
Yeah, thanks, Derek. With the raw measurements that Derek talked about, he mentioned the vertical distance and horizontal distance that's calculated, but the units also have a height routine on them, and the height routine, 3 shots, is going to be best for these upright objects like a phone pole or something like that, something that's where the top is right over the bottom, because that first shot is going to be horizontal distance, and that's really going to set up all the geometry for the height measurement. So you need a nice vertical object where that HD is, that distance would be constant no matter where you shot it. And speaking of that, you can shoot it anywhere. If the base of the pole, for example, is obscured by brush, you can aim up here where you've got a clear line of sight to it. Anywhere on the pole, you get that HD for your first shot. Second shot then is just an inclination measurement to the base of the pole. Some of you that are on the call today that have our lasers can kind of follow along with this procedure here. That second shot, you're not measuring a distance. So if there is brush down there, you just visually estimate where the base of the object is and take your measurement. So that kind of sets up the distance and the base of the object. Now you're just going to measure a top angle to wherever you want that HOA. So here we're going all the way up to the crossbar, for example. So that shot 3 would be again just an angle, and that'll complete the measurement and give you your height result. So again, that's shot right out the serial port if you happen to be collecting data, and that measurement's recorded. So in this case of example of pole audit, you're going to want to measure several heights on that object, right? So you don't want to have to take that distance and base shot again. What you can do on any of the laser models is just press the back or the up key, one press, and it'll back up a step and allow you to take that top angle again. So now you can come down and get a shot here to the transformer, down here to one of the comm cables, and it's just backing up one measurement and then reshooting, and that data is calculated and sent out the port. So a real efficient way to get through all your height measurements. So we can also get height with the missing line routine. That's another routine that's on board all of our lasers, 2D and 3D. Missing line, we call it, and it's kind of shot 1, shot 2, and then you get the information in between those two. So let's say we want to get the height of this tree over here off the right of way. Trees, this one's represented pretty vertically here, but they don't often grow where the top is directly over the bottom. So this missing line routine is a much better way to get this vertical distance or height value we want. So this does require a direct line of sight and a direct shot to both targets. So you do have to see into the base of the tree here to get this shot. If you can't, you can put a marker up above the obstruction and just apply an offset after your measurement. So shot 1 to the base in this example, shot 2 to the top. And if you're really after a good tree height, you can kind of poke around up here and try to find the highest point on there. Sometimes it's not the highest from your line of sight. So you take that shot 2 and then you get the result. And then you just have to scroll one key on the side there to see the VD value. The resulting missing line vertical distance value would be your height for that object. So a great way to get heights of objects that are leaning. And again, it's got that multiple thing. You need to record multiple heights on something like that. You can just back up and repeat shot 2. So that's got that same capability. So another one of our measurements that we needed was span, or that horizontal distance between two objects. In some cases, it may be convenient to occupy one point and just shoot directly to the other. So you would just read off that calculated HD value, horizontal distance value, and that would be your span, or your distance between the two objects. But say you want to do it remotely from across the street or something like that. You want to get the span between these two poles. You take shot 1 to one of them, and here you're going to use the compass. So it's a 3D span routine. This is where the compass is going to come in. You're going to have a 360 model to do this. So you take shot 1 here to one pole, shot 2 to the next, and you get that resulting HD value, missing line, HD value would be your span. So a great way to get distance between two objects that are remote, inaccessible to you or something like that. And if you did happen to shoot them at the exact same spot on them, say this low comm wire, if you look at the VD value, you can even see the change in elevation between those 2 points if you wanted to. So a lot of applications for that missing line routine. Another way we can use it is to define sag. That's another value that's recorded often. So it's shot 1 to the attachment point, and then shot 2 to the low point. And then you see that resulting, again, vertical distance value for the sag. And that shot 2 can be repeated. Maybe you didn't hit the lowest point on the cable, so you can just move around there and repeat that shot 2 and get your greatest sag value for that maximum. So hopefully some of you in other industries can kind of start to see some applications for these. This missing line routine is really useful. So for example, to get clearance over a roadway, you take shot 1 to the wire, and then you've got to take shot 2 to the roadway there, right? And it can be kind of difficult to judge where that is depending on your perspective. So a little tip you can do is when you take shot 1, you note the HD value. It's right there in your display, right below right above the crosshair that you're looking at. So you just note it, it's 104 feet. So then when you come down here taking shot 2, if you've come down straight vertically and you measure that same distance, HD distance of approximately 104 feet, you're right below that cable. So you just take that shot 2, accept it. If you need to back up 1, you can do it, retake it. Once you've got it good, you accept it, and then you look at your VD value for the clearance. So great way to get those clearance values over roadways or walkways or something like that. So we'll talk a little bit now about on the transmission side, in particular doing some vegetation management. And in a 2D scenario where you've got one of the TruePulse 200s, you really have to position yourself right in line. If we wanted to get that minimum distance of this vegetation to the wire, we would want to get right in line with it, 90 degrees from that line. So you have to position yourself properly with the 200. You don't have that compass to rely on. So then you just take shot 1 to the point of the wire that's right above you. Take shot 2 over to that nearest point of vegetation on the tree or whatever it is. And then you look at your result. And in this case, when you look at your little blue resulting triangle here, the value you're after really is that slope distance value. That's that direct line distance between the vegetation and the wire. So you just position yourself at 90 degrees to the danger trees or the ones you've assessed to be a problem along the right of way, and you take your measurements this way, and you can get them real accurately. And then just like getting span or something like that, if you have the 360 model, you can stand off to the side here. And now you can take shot 1 to that, hot spot on the vegetation, and then take shot 2 over to the wire. And if you use that same technique we talked about, measuring to the same horizontal distance, that's going to be right there in that plane between those 2 points will be the value you're after. So you just repeat that shot 2 till you get that HD, and you're going to really be looking to minimize that slope distance value between there. So just a couple techniques for doing vegetation management along a right-of-way. So Derek, if you could mention a few of our solutions we got for documenting some of these measurements.
Yeah, no problems. We've been talking about Bluetooth communication and these measurements going out the serial ports, Bluetooth and the serial port, and it's kind of, it's like, okay, what do I do with that information, right? Handwrite it out there, or there's a lot of different apps. So at LaserTech, we do actually design some of our own apps. The first one we call is Measure. And so it's a LaserSoft Measure app. It works with our True Pulse product line. And so again, it works on Android and iOS, depending on the model that you have. And what it does, it's capturing that raw values that we've been showing you. You can see over on the right-hand side, the screen there, those different values, HD, VD. So you can see these values populate right into the app. But we can also capture a height measurement or a missing line measurement that he's been talking about. So we can capture that right away. You can make notes of that, different notes. You can make little projects there. It's a really simple free app that we have available to interface with the True Pulse line. You can also take a picture, just so documentation. I mean, our pictures of, right, 1,000 words, whatever it is. So you can take a picture of it too for documentation purposes. So you have all that there. You can see these images on the right there in the screenshots. That's actually we've taken what we call a phone scope, and we've attached the phone with the camera right behind the heads-up display of the True Pulse. So we're using the camera on the phone, looking through the True Pulse to capture those values on the heads-up display. So you can see that that's really powerful to capture that right there. You know what you're looking at, and you see those different values. So that's a quick, easy, free app. There's another app out there that is kind of more a form-based app. Also has some georeferenced portions to it too, but it's a really good form-based where you build up, like Steve talked about, all those different heights that I need to capture for attachments or the conductor or transformer or whatever. You can build this form up already, and then you just go out there to the field and start taking these measurements. It's called GeoJot Plus. It's a photo-based form-built app that's available for you. It does interface with all our lasers. One thing is that you can also georeference the position. I'll talk about that here shortly. But what it is, you can take photos of the image, do a height measurement of the full utility pole there. Then you can take all that information back to the PC program, and you can do some measurements on the PC program. But you have to have a reference height already done. So you have to use a laser to get that reference height, or you can just use the laser the whole time and just take all the measurements you need to get those measurements right in the field and see that right away. And what I meant about like georeferenced, what we call laser offset mapping. This is integrating our lasers with different GNSS devices and different apps. So What does that mean? You occupy a position, you know, safe location on the side of the road, get your position. And with our laser, using our 3D lasers, that's going to give us our distance and tilt and our azimuth value. You take a measurement to that utility pole that you do not want to stand by all the time. Take that measurement, and the app actually does the calculations for you. And it'll calculate that remote position. So no need to walk up to every pole and get a position, then back up and then do a height measurement. You can stand again on the other side of the road, take the measurement, georeference that point, then do all your height measurements right there. We've been working with Trimble for many years with integrating our lasers into different Trimble devices or different apps and solutions. And they've released a new app over the last year that we've been working with. And actually, Peter's going to talk a little bit more about how our lasers interface with the Trimble products.
Absolutely. Thanks, Derek. And Derek knows quite well how excited I am about the laser offset capability in TerraFlex. It's something we've been talking about for a good 3 years now, so something we're really, really thrilled about. Before we jump into TerraFlex, one thing I'll note on all of the routines and feedback I've gotten from utility customers and telecom contractors is just the speed, how much faster they're able to do specifically pole audits with the laser. You know, the height stick is a two-man operation. You have to physically go to the pole, lift the height stick and get that elevation. It can be a little cumbersome. So the feedback I generally receive is we can be much faster, which, you know, the faster you're able to move, the more money these contractors are able to make. So that's some of the good feedback. But TerraFlex is Trimble's cloud GIS data collection software. It works with our Trimble Catalyst TDC 150 line, our R series, which are probably our more popular, our BYOD or bring your own device series. So those are Bluetooth receivers, both the R1 and the R2. And then there's the 200 series and the 360 series provide that laser offset within TerraFlex. So why would we want to do a laser offset when doing data collection? Well, these three images are great. They show you exactly why. Nobody wants to get hit by a car. Let's say we do need to collect that manhole in the middle of the street and we don't have a street crew available to stop traffic or divert traffic. We can collect that manhole with an offset. Same thing where we've got areas where you simply can't get a GPS signal. Let's be honest, GPS just doesn't work when you don't have access to the sky. So anytime you're in, this is a great example, really dense canopy. I've got a real world example. I've got a customer, a gas utility actually, so not electric. They are having trouble getting meters in some of their neighborhoods that the houses are extremely close together and they're very tall houses, 3-story houses. So when they go up to the meter and on the side of the house, they simply are not able to get a good view of satellites and get a good GPS location. So what they're using is a 200X with an iPad and TerraFlex, and they're able to, from the street, collect most of the meters in the neighborhood. So yeah, that's exactly how it's done. So we can do both a distance bearing and a distance routine, very similar to what we used to do in TerraSync, which a lot of people are most likely familiar with. 200X is going to be done with distance on Android and iOS, whereas 360R will give you that distance bearing on both Android and iOS.
Yeah, that's great, Peter. Yeah, the workflow, if you kind of look at this picture on the left to get that manhole, this may not be a very good environment for the compass, right? So you might want to do the distance here. So the workflow would be you'd grab a first position there, shoot the target with a laser, and then you'd move down the road, 50 feet or something like that, and grab another GPS point there, shoot back at that same target, and it'll do that intersection for you, right?
Correct.
Right, and TerraFlex is great because it gives you that instant feedback. That's something that I really liked about it. It'll estimate your position accuracy based on the GPS and the laser data for that point you're taking. So you get that instant feedback right there, whether the data you're collecting is going to pass muster, right, and be within your accuracy limits.
Exactly, and I'll say that the TerraFlex interface for doing these offsets are the best I've seen. I've been blown away with just how easy that workflow is, how easy that interface is. So if anybody on the call wants a little more information on it, we can certainly set up a demo, and we've got recordings of previous webinars on our site as well that do a full-blown demo of that routine.
Yep, great. Okay, that's the content that we had for you today. We've kind of looked at how a lot of these measurements need to be made, and again, there's a lot of crossover into different industries. We took the electric utility industry here as an example, and the pole audit app, but many more to be answered by the way the LTI products can make these measurements. They make them safely, from a safe location, and measuring more, move less. This gets to Peter's point about how you get increased speed out of your workday, and maintaining that high accuracy for sure. So we looked at a few of the data collection options then, and then got into some of the remote measurements too. Some of you may make these GIS type data collection scenarios yourselves, or maybe you have a department that does it, but it's definitely a good marriage of the two technologies, where you are on the map and then where a remote object is as well. So some resources that you can have besides reaching out to myself or Peter, anybody at Duncan-Parnell. Both the companies here have YouTube channels, Duncan/Parnell, and then LaserTech Pro. You can go there for other resources that Peter mentioned, video on the Teraflex integration, and we've got one here, for example, on the GeoJet application that we did too. So there's those good video resources there. So just that wraps up our webinar for today. Wanted to thank everybody for joining us. There's contact information here if you need it. Any other questions that may have come through I haven't seen, or any other comments from you, Peter or Derek?
I will just say thank you everybody for attending. I haven't seen any questions, but we're ecstatic to be a LaserTech partner, and it's been great to work with you guys, and looking forward to continuing to do so.
Thanks, Peter. Yeah, it's our pleasure too, and really appreciate you guys bringing this information to your customers out there.
Yeah, definitely. Thank you. Thanks, everybody. Thanks, Peter.
Thank you. And as a reminder, this is recorded, so everybody that attended and registered will get a link to the recording, and we'll have it available on our website as well.